There we go. Okay, so we're going to continue on in our PowerPoint, and we're going to start here on the slide number 19 of 24. So graphical disk cam profile. So we are now going to be leaving, if you would, the displacement diagram gives us a graphical of how that motion is going to be for our follower. But now we have to generate the actual cam profile that it is actually going to be riding on. So this is going to be the graphical solution for doing that. Now, what I'm going to do is we are going to be looking at figure, I don't think I like that one. We're going to look at figure 921 on page 239. Essentially very much the same thing, and we're going to see the same items listed here, but I just like this illustration a little bit better. So we are going to go to this page right here. So again, this is page 239. And what this is an arrangement of the type, one of the types that you're going to be doing for an assignment. As we look at this arrangement in terms of the follower in relationship to the center of rotation of the cam, this is considered an inline roller follower. Okay. I'd like everybody to pay attention. I really, the things that are getting handed in, there are things that are being missed. And I think it's because people aren't following along. Okay. So when I'm lecturing, I'm giving you the new information, and my focus, I assure you, is going to be things that are going to benefit for your homework. I understand the urge of wanting to jump to the homework and just do that, but you're going to be more efficient by listening. So when I get everybody's attention and we're looking up here and not on our computers, I will continue on. Okay, thank you. So this is an inline follower. So you're going to notice here that the follower itself has a roller on the end of it. It is in a vertical position, and if we extend, it is going to extend down and through the center line of the rotation of the cam, okay? And down here is the center of rotation of the cam itself. Now, the part that we're going to be creating is we're going to be creating this cam profile. So this is going to be the irregular shape. So it's not going to be a circle, that is going to be centered on rotation. It's actually going to have some, irregular shape or lobes that are going to be created based on the actual requirement for the motion that we had looked at earlier in this chapter. Now, what you're going to see here is you're going to see the roller in its what we call home position, okay? And that's going to be at 0 degrees. So if I scooch this up a little bit, you're going to notice that this is our home position. Now, something to note. Notice that the W of the cam, this is going to be the rotational direction of the camshaft when it's actually rotating. It is identified here by the W going in a clockwise direction. When we know that the cam is rotating clockwise, we are actually going to be generating the profile and constructing it counterclockwise. So it's going to be opposite. So if it says in the problem that the cam is going counterclockwise, then we are going to be generating or creating the profile in the opposite direction, which would be clockwise, okay? But in this case, it's going clockwise. So you're going to notice that our 30-degree position here is going to be then in, if you would, the counterclockwise direction. Because what happens here is this is going to rotate. And so you can see that the next position that's going to be here is the 30 degrees. That's why we construct in the opposite direction. So what they've done here is from the center here going off, they have done in 30-degree increments, what is the position of the cam? Now, up at the top here, this is going to be its base position. And you're going to notice that as we move from one to the next, there is created this little bit of gap off of what we call the base circle. The base circle is going to be the circle that's generated from the home position that if indeed we would rotate around it and we would stay in that same position, it would be the circle that would be created. If you would, it's also going to be the bottom of the displacement diagram, because each one of these offset distances here, you're going to notice that from the center of the roller, and if you look close at the 30 degrees, it doesn't move much, but there's a little bit of an offset there. That is the distance that we would measure on our displacement diagram for the displacement of the follower. So for instance, if we go back over and just in the page of previous, there's a simplified version of a displacement diagram here. So if we look at where 30 degrees would be, we would notice that if we would measure from the base, okay, this is considered the base circle. This is where we start. And we would measure from here to where the line is on the displacement diagram. This is the distance that at 30 degrees, that roller has to move out, okay? Then we're going to go to 60 degrees, and we're going to go over and we're going to measure. Okay, now it might not be exactly the way it looks here, but we're going to measure from here, from the base to the displacement on the curve at 60 degrees. And we're going to take that distance, and that is going to be translated over to this distance here. We don't know what the scale of that other drawing is, but that's what the displacement diagram is for. It's for identifying what is our displacement of our follower. And now when we construct the profile of our cam, those are the distances that we're going to use at the corresponding angles. So now if we go to 90 degrees, okay, notice that distance there along that line. We would then measure this distance from here to here. And then we would translate that over. And we go all the way around that circle. Now, you'll notice that the example that they do here, as well as for your assignment, you are going to be doing it in every 30-degree increments. That's enough, okay? That's enough. And it gets us what we need. But if you wanted a more accurate, smoother curve, you could then add degrees in between. So if you wanted to do it every 10 degrees, or if you wanted to do it every 5 degrees, you could do that. And the more points you have, the more accurate that profile would be. Okay, but we're going to, for practice sake and getting enough, of the process, we're going to do it every 30 degrees. Okay, now once we have our offset or our position of the roller along the outside there, then what we're going to do is we're going to generate the profile of that cam first through the center of each one of those rollers. Now, based on your CAD knowledge and how you generated the curve for the displacement diagram, how do you think we're going to generate that curve going through all of those centers? What function or what command would you use in AutoCAD to generate that? Go ahead, Ben. A spline, exactly. And I think it's called spline fit. Is that right? The same one that you use to generate your curves for the harmonic or the cycloidal motion going in and out. You're now going to use that very same command to pick on the centers of the new position of the rollers. And then you are going to, once you have that curve, now that's through the center of the rollers, we want the path or the profile of the cam. You're going to simply, once you get that in place, that's going to be a continuous polyline, if you would. And then you're just going to offset it the radius of whatever the roller is. And then that is going to be your profile of the actual cam itself. Okay. So my job today is, I do not want you to worry about following along in an AutoCAD demonstration. I am going to give you the basics of how to construct. In this case, the first one that I'm going to demonstrate is going to be an inline roller cam. And this is going to be similar to the one that you're going to be doing for your homework. And then I'm going to do an offset roller, and we'll talk about that after we get done with this first one. Now, the problem that we're going to demonstrate, there are no examples in here. And again, I'm going to demonstrate this. You don't have to do it with me. All I'm going to do is I'm going to go through and give you a demonstration of the process that you're going to take. Now, the homework problems that you have, go back just a second. The first homework problem you have is going to be problem 939, okay? And that is going to be very similar to 940. I'm going to demonstrate 940, okay? And then you're going to use this process to apply to 939, okay? So both of them are in line followers with a plate disc. And there are some differences here. So we'll just go through and we'll talk about example or problem 940 as our example here. So this is going to be a plate cam that must provide displacement shown in figure 939. So what they did, I'm going to turn the page here. They have kind of a stripped down displacement diagram. But then what they did for every 10 degrees, they identified what the follower displacement was. So they went ahead, if you would, and measured each one of these distances all the way along in 10-degree increments. For the example that I'm going to do and for the assignment that you're going to do, we are only going to do it every 30 degrees. Okay. Otherwise, it's going to get really long. Okay. And this will give us enough practice to understand the process. So you're going to notice here at 0 degrees, the displacement is 0. At 30 degrees, the displacement is 0. But then we get to 60 degrees, and now we've got a little bit of displacement, and then it grows, and then it falls again. Okay, so on every problem that we do, you will always need a displacement diagram to start first, which is what we did in the first couple example or the first couple problems in the assignment. Now here, we're going to use a displacement diagram that's already generated for us, use data that we collected from it, and we're now going to create that profile, okay? So this is going to be where we get our data from. Now, the roller diameter is 3/4 of an inch, and the cam must have a base circle of 2 inches, okay? And it's going to rotate counterclockwise. Graphically construct the profile and estimate the largest pressure angle. Okay, we're not going to worry about pressure angle, so you can just cross that off. I'm not worried about pressure angle. All right, so what I'm going to do is I'm going to go over to AutoCAD, and we're going to see the information that we have here. So let me go underneath here. Okay, and extends, and I'm going to go over here. Now, first of all, this is going to be our final result. Now, again, I'm not expecting you to follow along right now. I'm just expecting you to watch the demonstration here and so that you get an idea of how to do this. Now, in this problem, it told us that this is rotating. This cam is rotating counterclockwise. So notice that I have kind of this arrow up here. This is the rotation of the cam. So I am going to be generating my profile in a clockwise direction. So my vertical line here is going to be my 0/360 degrees on my, if you would, displacement diagram. And you'll notice that I have a 30-degree increment going clockwise because it's opposite that of the rotation of the cam, okay? And then I did in every 30-degree increments going all the way around, you know, back to 360 degrees, okay? Now, so the first thing that I did, I'm going to kind of go back and forth between these. I made my 30-degree increments here, okay? And those are going through the center of rotation. Now they're referencing for us in this problem a 2-inch base circle. The 2-inch base circle is right here. And what that is that is going to be the circle for which the roller would be on in its home position. So if I'm right here, my roller, since it has a diameter of 3/4 of an inch, offset from there 3/8 of an inch is the center of our roller. So my roller is right here, and this is my base circle in green. So if we look over here, my base circle, I do have it dimensioned as 2 inches, okay? And then my roller is 3/4 of an inch. So notice that they're in line with one another and they're touching. We call it the base circle because this would be the base, if you would, of your displacement diagram. It would be that bottom, if you would, line of that diagram. Okay, so this is kind of what you construct first. You're going to put your lines in place for each one of the angles in the correct direction. So again, going clockwise here because the rotation of the cam is counterclockwise. I put my roller in position, and then I put my base circle in position. Okay, the next circle that you're going to see on here is what we call the offset circle. The offset circle is simply the circle that would go through the center of our roller when it's in its home position, as if it would stay, you know, in that same position going all the way around. Okay, so all that is it's going to be offset, if you would, 3/8 of an inch or half of the diameter of the roller. And that is going to be kind of, if you would, the base of the roller position. Okay. So right now, any questions on what I have over here, kind of starting with kind of the basics. Okay. All right. So base circle, 2 inches. That's the green. Roller diameter, 3/4 of an inch. That's the blue. And then all of these like center circle or center lines and this circle, this is going to be our offset circle. And all the lines are going to be the increments of the angles that we're going to be identifying. Okay. So now what we're going to do is we're going to start using the information from the chart. So if we go back to page 256 and we look, okay, on the chart, it said at 0 degrees, this is going to be our 0. And we're expecting that because that's the home position, if you would. That's where everything starts. And then you're going to notice at 30 degrees, it's the same number. It's 0, 0 on our distance. So I'm going to go back to AutoCAD. And what that means is in the 30-degree position, this right here is the base of that circle, okay? That means that its center is going to remain on there because there is no offset from that. So I'm going to just simply copy my circle from its center to the intersection of the line and the offset circle, because in both cases now these are going to be on that same distance, if you would, of 0. Now I'm going to go back underneath and I'm going to go down to the 60-degree mark. At 60 degrees, it says, oh, we're offset. The follower displacement is 0.091. Okay. Well, now I have something that I have to generate. So I'm going to go back to AutoCAD. And now here's my 60-degree mark. Okay. I'm going to take this circle right here and I'm going to offset it that distance. And I'm going to offset it outside. So I'm going to use my offset command. My distance is going to be 0.091. And I'm going to take this circle and I'm going to go to the outside, not inside, outside. Okay. And now this intersection with that new offset circle that I have and the 60-degree line is going to be the new center for that position on the roller. So I'm going to do copy. I'm going to take the roller from its original center and I'm going to now put it at the new center, offset a little bit. So notice here that we see that kind of start moving away from that base circle, okay? Now, what I've been doing is I've been trimming this circle from here to here, then just getting rid of this, because that way I can see that difference to the center, okay? Now I'm going to go back underneath and I'm going to go to 90 degrees. 90 degrees is an offset distance of 0.5. So I'm going to go back to AutoCAD. I'm going to do an offset. I'm going to go from, or actually I put my number in, 0.5. And I'm going to go from that original circle out to that point. And I'm going to copy from this intersection to that intersection. And again, I'm going to trim. I like doing this because then I know exactly where it was. And so that's going to be then my new center. Okay. And then I'm going to continue all the way around. So let me do the 120. 120 down here is 0.909. Okay. So again, offset. And it's going to be 0.909. And I'm going to offset the circle out. So here's my new center. So I'm going to copy from this intersection to that intersection. And again, I'm going to leave the inside here so that I know where its center is. Okay. And now you're going to continue that all the way around. So you can see how each one of those offsets then created that outside. So I am going to do the next one. Oopsie. So 150 is 1 inch. So I'm going to do an offset here. And then 180 is also 1 inch. So both of those will be at the same position. So from here to there. Now, if we look at the data for this one, what is kind of nice is you're going to notice that as we start going in the opposite direction, the numbers are the same as the other side. So what this offers us is the ability to, possibly do a mirror if we can. So I go back over here. I'll be able to, can I? Oh, maybe I can't, because I've got 1, 1. Oh, I don't think I can, because now it's going to be on this one is going to be the new. So got to put them in manually. That's okay. 0.909 is going to be here. So I can just go from here to here. And then 0.5. I just need to get them in here, and then I'll show you what you'll do on that profile. To the intersection. And then 0.091. And I think the last ones are at the 0 degree. They are. So then now I can just go from here to there to there. Okay. And then I can get rid of this. Okay, so now I have all of my rollers in position. So now through the center of each one of my rollers, I am now going to generate my spline. So I'm going to change to the center, just because that's the one that I have going through there. And I'm going to go down to the draw command, and I'm going to go all the way over to the left, and this is going to be the spline fit. And I'm going to go from the center of each one of my rollers, and it's going to generate that spline going around. Center for these. I took the center off because sometimes it just gets in the way. There we go, intersection, and then the last one. Now, something about this command, don't hit escape at the end of it like you can for others, because otherwise it'll all go away. You've probably experienced that already. Just go kind of away from it and hit enter when you get to that last point. And now this is the spline that's created, okay, through the centers of the roller. But for the profile of our cam, we're going to offset that 3/8 of an inch, okay? So, whoops. So I'm going to hit offset 0.375, and I'm simply going to select my spline and go to the inside. And now it is going to be tangent to all of those lines. I'm going to change this to the object layer, and that is going to then be the profile of my cam. Okay. So that's the process that you would take. Now, as far as labels, okay, the labeling that I would like you to do is going to be, what you see here. So I want to see the angles in the opposite direction. I want you to identify the cam rotation. So I have this very simple little, okay. And then I also want you to dimension, for instance, at the very minimum, I want you to dimension the diameter of the roller, okay? The diameter of the base circle, make sure that that's in there correctly. And I think that's about it. I think that's about it. I'm going to change these to go on the correct layer. Right? So any questions as you kind of look here? Does that make sense to everybody how we generated that profile and where the offsets come from as far as the displacement diagram at each one of the angles? Okay. Any questions at all? All right. So I'm going to just do a quick save here. Then we have one more to demonstrate. So if we go underneath, yeah, I didn't do these. Okay, that's all right. I'm taking a little bit different approach. So the other one that we're going to be looking at is going to be the offset roller follower. So your homework is going to be number 41. We are going to be doing number 42. So on page 256, we're going to look at example 942. Okay, this is going to be another play cam. The displacement diagram is going to be directly above the same set of information that we used on the previous one. You'll be using that same set of information for both of your example problems. Now, the follower is to be positioned in the vertical plane, so straight up, just like we had it, contacting the top of the cam. The offset distance in this case is going to be 1/2 inch to the right of the cam center. The roller diameter is 3/4 inch, and the cam must have a base circle of 2 inches. So similar to what we had before. And the cam is rotating counterclockwise. Graphically construct the profile and estimate the largest pressure angle. You do not have to estimate the largest pressure angle for our examples or our homework problems. So let's go and look at problem number 42. So I'm gonna look at kind of our end result to start. So how this is different is that our follower is going to be offset from the center. So as you know, if it would be in line, it would be directly above here at its 0 position. But we are offset 1/2 inch to the right of the center. Okay, so this distance right here is 1/2 inch. Now, the center of rotation is still going to be in its part, but the follower is going to be offset by 1/2 inch. So I'm going to go over here because that's our final. I want to kind of go through this process. Base circle is 2 inches. Then the offset circle is going to be half the diameter, or offset of half the diameter of the roller. This is 3/4 inch, and we are offset by 1/2 inch. So if I do a dimension here, this is going to be 1/2 inch. Okay. And it told us to the right. Now this cam is rotating in a counterclockwise direction. So again, we're going to be generating in a clockwise direction. Okay. So the first line here that I have is I drew a circle that has a radius of 1/2 inch. That's going to represent that offset. Then from that, and this diameter out here, I just created so that I would have something to extend my line to. That's the only purpose for that. Okay. You could even delete that afterwards. And then this line represents the offset through the roller. Okay. For its home position. So that's its 0/360 degrees. Now, what I want to do is I am going to now create the 12 lines going around that are going to be off of that offset circle. So I'm going to go to array, and underneath array, you probably see it. I think the default is a rectangular array. You're going to go down to polar array. So you're going to click on that. You're going to select the item that you want to do a polar array on. You can hit enter. And now you want to specify the center of rotation. That is going to be the center of rotation for the cam. So I'm going to click down here on that center. And now a new menu is going to come up, and it's going to like want you to fill these in. So we need the number of items to be 12. And if you just hit enter here, it's going to automatically update it so it's evenly distributed around 360 degrees. Okay. If you need to, it is going to be 30 degrees between each one. And now what it's done is it's generated an array of the lines that are offset for us. Okay. So using that array command makes that really easy to do. And then you're going to notice that that's going to correspond to, in a clockwise manner, 30, 60, 90, and so on. Okay. Now we're going to do that same process except you're going to be going along these offset lines to position your roller. So if we go back underneath, okay, we know at 0 degrees, it's 0. At 30 degrees, it's 0 again. So if we go here, we're going to copy our circle from its center to the same center that's on that base circle because it's not moving at this point. That's a 0. Then we're going to go back, and now at 60 degrees, 0.091. So now from here along the 60-degree line, so here's my 60-degree line, I'm now going to copy from this intersection to that new intersection. So now it's gone out a little bit, okay? I'm going to get rid of this just so there's fewer lines. Then we're going to do that same thing, that same process. Now we're going to offset 0.5. And we're going to copy the roller from its center here to the intersection there. I'm going to turn on center. Go that way, it'll grab it. And I can get rid of that. And then we're going to do that very same process all the way around. And again, along the offset lines, okay? So when you hand in, I want to see the offset lines. I want to see the rollers in position. And then you're going to do that very same thing by putting your spline through the centers first. So draw spline fit. And you're going to go through the centers to start. Okay, and I'm just going to go that far. Okay, hit enter. So I've got that spline there. And then I'm simply going to offset it 0.375 or whatever the whatever the radius of the roller would be. Okay, it might be different. So make sure that you read that. And then this becomes your cam profile. Okay. So any questions on that process? All right. You are going to do an inline roller and you are going to be doing a offset roller. All right. So if we look at the homework underneath here, the two problems that you're going to be doing, the last two problems in this assignment, you're going to be doing 939. This is going to be a plate cam. It's going to provide the displacement as shown. So again, the same chart that we looked at for these two examples. The roller diameter now is going to be 1 inch. The cam must have a base circle of 3 inches, so different diameter. And this one is going to rotate clockwise. So that means you're going to be generating your profile counterclockwise, opposite direction of the rotation of the cam. Graphically construct the profile, and you don't need to estimate the pressure angle. Okay. So you can cross that off. So that's the first problem. So that's going to be like the demonstration I did on the first one, the inline roller follower. The second one that you have is going to be number 41. This one is going to use that same data above, but this is going to be an offset roller follower. The follower is going to be positioned in the vertical plane, contacting the top of the cam. The offset distance this time is going to be 3/4 of an inch and to the left of the cam center. The roller distance or the roller diameter is going to be 1 inch. The cam must have a base circle of 3 inches and the cam is going to rotate clockwise. So you generate counterclockwise. Graphically construct that profile. You do not need to estimate the largest pressure angle. Okay. So you can just take that off, just the cam profile. All right. Now, if you're working and you're like, I want a little bit more direction on the construction, we go back in our chapter. The two places that you want to look, if you want to see in the book how they have the construction, on page 239, this is an inline roller follower. That's going to be similar to the first cam profile that you do. And the second one is going to be the offset roller. So really in, sketch form, if you would, what you would do in AutoCAD. Okay, so those are there for you. Does anybody have any questions? Because that's really that's the information I wanted to give you, and then give you the opportunity to have time to work to complete these last two examples, or last two, I should say, homework assignment problems. All right. If not, then what I'm going to do is I am going to stop the recording